Hey everybody, welcome back. Hope you're all staying safe out there. Wanted to continue our discussion on factoring polynomials that are in the form of ax squared plus bx plus c. Now we started it out yesterday and the video was kind of a lengthy one, and I know that it's kind of one of the tougher topics, at least in my experience, for my 8th graders in Algebra 1. So I wanted to give a second chance to go over it today and kind of extend a little bit what we set yesterday as hopefully our foundation. So yesterday we were talking about how these are not questions you can just do in your head. There's no way to say, hey, can I think of two numbers that multiply together to equal -10 that add up to equal -7? I cannot do that on this one because the a, if you see up here, the a is always the coefficient on the x squared. Whatever the x squared is being multiplied by, on all these questions, the number is bigger than 1. And so whenever that a is 1, we can do it in our head, but whenever the a is a different number and it's not the number 1 as your coefficient, you've got to do a little work to figure it out. So unfortunately, the work or the strategy that we had is the guess and check method, which is not everyone's favorite because sometimes it can get a little bit time consuming, but unfortunately, that's what we're just going to have to do on these. So I made one quick example. You can see this is an expression. My second one down here is an equation where it equals 0. That's the extension that we're going to look at today here in a second. But before I get to that, just a basic question where it's a normal expression and it asks you to factor it. The instructions on this question would say factor the polynomial. First thing you want to look for is a greatest common factor. Is there something that all three numbers can go into? And I see the 12 and I see the 10, and that makes me a little bit hopeful. Oh, maybe they can both be divided by 2. Maybe everything can be divided by, wait a second, 7 doesn't go with 2. So there is no greatest common factor. And so now what I just have to do is I have to guess and check. Okay, what does it mean to guess and check? All right, so I know it's going to be 2 parentheses because that's how these always work. And I need to figure out in my FOIL what were the possible combinations that they multiplied here when they did the first thing in this parentheses times the first thing in this parentheses, right? They had to get an answer of 12x squared. I'm looking for combinations that would equal 12x squared, right? So it could be 12 and 1, probably not. It could be 2 and 6. It could be 4 and 3. And obviously I could reverse those around if I needed to. But those are my 3 combinations. Most of the time, it is not the combination that involves the number 1, so I'm going to do that one last. We're just going to have to make a guess. That's why it's called guess and check. We're going to make a guess, and maybe for this example, let's guess 4 and 3. Let's guess that it was 4x times 3x. I think that might be maybe the one I want to go with for the letter F. Now, with the same thing in mind, here at the end, the letter L is -10, right? The last term in this is -10. And so how did they get -10? Well, it could have been 10 times -1, 5 times -2. I could have all these reversed, right? 2 times -5, and 1 times -10. It could be one of those 4 combinations. It's probably not the one that has the number 1 in it. So it's probably the ones that have the 5 and the 2. Maybe just for my benefit, let's try this one, +5 and -2. We're just going to go down the list. So I'm trying this combination with this combination. We're just going to guess, and now we need to check it. How do I check it? Okay, I've already set up the letter F in my FOIL. I've already set up the letter O, or the L in my FOIL, because I looked at the last part. What I really need to check is right here. I'm looking for the O and the I. I need the O and the I when I multiply them together and then combine the terms to equal -7x. And so this is where I'm checking, right? I'm going to check my work. Here are the 2 outside terms, the outer terms, the O in FOIL. If I showed my work off to the side, the O, the outside is 4x, and this is -2 because it has the subtracting in front of it. So 4x times -2, that's -8x's. And then I want to look at the insides, the 2 terms here on the inner part of the question. The inner terms are +5 and then 3x. So 5 times 3x, that's 15x. And oh man, we got so close. Look at what we had right here. Our O and the I, if I combine these together, -8 plus 15, -8x plus 15x is 7x. I have +7x. That was so close. Look at what my target was over here in red. My target is -7, and I got positive 7. So I'm incredibly close. I talked about this in my video yesterday. What it means, if you get the right number, but your sign is wrong, right? I got 7, but I got positive 7, and the question says I'm supposed to have negative 7. All that means is my numbers are in the right spot, so don't mess with the numbers. All that means is my plus sign and my minus sign are backwards. So instead of 4x plus 5, I want to make it 4x minus 5. And my second parentheses, instead of being 3x minus 2, it needs to be 3x plus 2. And there you go. We got it on the second try, right? I didn't have to use these other guesses. I didn't have to try 10 and 1 or 1 and negative 10 or 5 and negative 2. I didn't have to try all those, right? I got it. So that's kind of what we went over yesterday. It's not the easiest thing. In fact, it's one of the tougher things that we learn in this class, and especially having to do it over video instead of being able to meet in person this year is going to make it even extra challenging. So that's why I'm spending 2 days on this. Okay, so how are we going to extend that idea today? How is an algebra assignment, an EOC test, a high school, eventually Algebra 2 assignment going to prepare this, or how are they going to present it to you? Eventually, they're going to make these equations. You see how here I did the same thing, except now I made equal 0? So now it is not an expression, now it's an equation, and it's asking you, hey, what does x equal in this problem? Okay. It's the same idea. We aren't going to have a freak out. We aren't going to panic. We're not going to have a stress reaction here. This is exactly like the last question. The only difference is it has the equal 0 on it. So what that means is at the end, we are going to have to do that zero product property stuff that we did earlier in the chapter, and that's not too bad. But let's actually get to the actual answer before we worry about all that other stuff. So let me go ahead and erase some of this so it doesn't distract and get in the way. All right, I'm going to make my guesses here. How do I think they came up with 6x squared for the letter F in FOIL? Well, it could be 6x times 1x. That's probably not it. It could be 3x times 2x. I'm thinking it's probably that. It could be 2 times 3. It could be 1x times 6x. Those are the only 4 ways to multiply together to get 6, right? We can't use decimals, so there's no need to try to get creative and come up with some decimal combination. Not going to happen. It's got to be one of these. More than likely, it's going to be one of the 2 in the middle. Let's just try this one since I wrote it first. Let's try 3x and 2x. And now we're going to look at the letter L. At the last part of my parentheses, it has to be positive 15. So that's either going to be 15 times 1, probably not. It could be 5 times 3, that one's decently likely, or 3 times 5, or 1 times 15. Those are the only ways to get 15 without using no decimals, no fractions, no crazy stuff, just using regular whole numbers, regular integers. Those are my only 4 combinations. I'm going to save the 15 times 1 for the end because that's usually not it. I'm going to try 5 times 3. So let me put 5 here and 3 here. Oh, I should have checked in the middle before I put those as plus signs. I almost made a mistake. Okay, look here in the middle. Our OI in FOIL, the O and the I, have to equal positive 19x. Okay, so that is a sign that these are both plus signs. If that would have been minus 19x in the middle, we would have had to switch those plus 5 and plus 3 to negative 5 and negative 3. But luckily we got it with plus signs there. So now let's just check. I made my guess. I don't know if this is right or not. Now let's check it out. Let's check to see if we can get our answer for the OI, the O and the I, as positive 19x. So on the outsides, way out here, the outer edges of the question, I've got 3x times 3. I don't have a lot of room. I'm just going to kind of squeeze it right here. And actually, this green marker is not writing very well. 3x times 3, that's 9x's. There we go. Now it's working. The I, the inner terms right here in the middle, that is positive 5 times 2x. So I'm going to check the outside, I'm going to check the inside, and look what I get. I get 9x and 10x. If I combine those, add them together, I get 19x's. That's exactly what I wanted. I got lucky. I got it on the first try. Leighton Crawford, there you go. Okay, so I got it on the first try, but I'm not done. I was done at this point on the last question. I was able to circle it. I was happy. I went on to the next problem, and it was all good. But look, this one, remember, equaled 0. So let me rewrite this statement. This is what we got for our answer. I'm just going to rewrite it so it's not so cluttered up there with all that other underlining and weird stuff around it. This is what we have right now. This times this equals 0. Remember how we learned this earlier last week and earlier in this chapter. This is a multiplying statement. Even though they don't put the dot in there, it's always there. We have a multiplying statement, and the answer is 0. We can use the zero product property to help us. Anytime you multiply something together and you get an answer of 0 for your final answer, you know that one of the two parentheses has to equal 0. That's the only way to get the answer of 0 to a multiplying question. So what number would you put right there to make this whole statement equal 0? Oh, geez, that's kind of a hard one. If you don't know that in your head, just say, okay, either this equals 0 or this parentheses equals 0. Right? So just make each parentheses equal to 0. We know one of those two had to equal 0. We don't know which one. And just solve each one. This should be an easy two-step equation, right? We should know how to do this. We did this way back first quarter of the school year. We're going to solve this for x. Divide by 3 on both sides. X could equal, right here, negative 5 over 3. Or, on the other side, subtract 3 on both sides instead of adding 3. And now we want to divide by 2. Divide by 2 on both sides. X could equal negative 3 over 2. So we have two answers on this question, right? This is going to have two answers. If there's an equal sign in it, equals 0, you're going to end up with at least one answer, usually two. Every once in a while there'll only be one, but usually you'll have two answers. Okay? That is about as difficult as they can make it today. All right, let me show you a couple more. I think I have 4 examples. Hopefully we'll do pretty well on these. Okay, first one and number 2 here. They're already equaling 0 for you. So this is looking pretty good. I can get this out of the glare. There we go. I made number 1 a little bit easier. Look at number 1. Doesn't it have a greatest common factor? Before I just start guessing to do my guess and check plan, can I actually divide everything on number 1 by 5? Right? Everything here goes into 5. I can factor out 5. I don't really like this green. I'm going to switch. Can I divide everything by 5? Sure I can. Right? Can I do 10x squared divided by 5? 10 divided by 5 is 2. Can I do 35 divided by 5? Sure I can. That's 7. And can I do 30 divided by 5? Yeah. Now, every once in a while, you'll get like me and you'll forget to do that completely. It's okay. You can actually do that at the end of the problem, but right now we remembered it. So now we need to do some guessing because these do not have anything in common. These 3 cannot be divided by 2. They can't be divided by 3. We're just going to have to guess and check. So now here is going to be our guesses. How do we think they came up with 2x squared, right? It's got to be 2x times 1x. That's the only way to get 2. I mean, I guess it could be reversed, 1x and 2x, but it's got to be one of those combinations. So I'm going to guess over here, 2x times 1x. At the end, how did we get 6? It could be, for the letter L, it could be 1 times 6. It could be 2 times 3. It could be 3 times 2. It could be 6 times 1. Okay, I've been preaching pretty hardcore in my last couple videos here. It's probably not the one that has the number 1 in it. And I don't even think it's going to be this one. Now, this is kind of an advanced concept here. Here's why I don't think this is the answer. Just look what the statement would be if I wrote it like this. Do you see something wrong with that? Specifically, do you see something wrong with this parentheses? If this was the combination, couldn't I get mad at this person and say, hey, wait a second, buddy. You didn't divide both those numbers by 2, right? You can still factor out a 2 on both of those. You can still divide both terms by 2. And so technically that answer is not 100% completed yet. And that's what makes me think that that combination is not going to be right, because that combination leads me to an answer that doesn't have itself simplified all the way. So I think this is probably the best guess to try first. I bet it's going to be plus 3 and plus 2, right? Because now these don't have anything in common. These don't have anything in common. That's a number 2, by the way, in case it's hard to tell. All right, I'm pretty confident that this is the answer, but I don't know for sure. Even though I've taught this class for a long time, I don't even know for sure. We're going to have to check. We're going to check the O and the I. We're going to look for an answer of positive 7x. Here on the outsides, 2x times 2. Okay, that is 4 x's. I'm about off my board over here. On the insides, right here and right here, 3 times 1x. That is 3x. And look what I get. 4x and 3x, that does add up to equal 7. So I got it. First try again. Now, I was so happy. I think that I'm almost done, and I am. Let me kind of clean this up a little bit because I have all this underlining and all this other stuff under here. Remember, this isn't just the actual problem. Remember, this thing actually equaled 0. I just forgot to write that. This thing actually equals 0. So I have a multiplying statement where the final answer is 0. The zero product property tells me that this parentheses equals 0, or this parentheses equals 0. Now, if you're very, very good at mental math, you can just say, hey, what number would go right there to make the whole parentheses equal 0? If you can do that in your head, go for it. But not a lot of people can do that in their head. A lot of you are going to have to say, okay, let's just make each one equal 0, and now let's just solve each one, right? Subtract 3 on both sides. You're going to get 2x equals negative 3, and then divide everything by 2. The first answer would be negative 3 over 2. Or if you wanted to call that negative 1.5 or negative 1.5, I'm okay with that. Over here, minus 2 on both sides to get rid of the adding 2. And divided by 1 doesn't really change anything. So negative 2 divided by 1 is just negative 2. So you have two answers. X could equal negative 2, or X could equal negative 3 halves, which is obviously the same thing as negative 1.5 or negative 1.5. Okay. You can see how we're putting together all of the things that we've learned this chapter. We've put together the pieces of FOIL. We've put together the zero product property. We're combining all these skills that we've learned throughout this chapter. So it's been quite a build-up, but this is kind of about as complicated as they can make it. Okay, number 2. Oh, man, I saw 15 and 12, and I thought, hey, can we divide? Oh, you know what? Let me actually back up. You might be thinking, well, wait a second there, buddy. You're getting ready to talk about the GCF. Whatever happened to this 5 way out here? Wasn't there supposed to be a 5 out here in front of your answer? And the answer is actually yes. But it really doesn't play a part in the answer because it's really only the parentheses that you're concerned with, right? This doesn't have a variable. And so honestly, you could say, hey, wait a second. Shouldn't you have said 5 equals 0 or 2x plus 3? Could you made all 3 of them equal 0? You could, but does 5 really equal 0? No, it doesn't. It's something we call an extraneous answer. Extraneous is kind of a fancy word for extra. An extraneous answer is an answer you get that doesn't actually apply to the question. So that answer really didn't make sense. 5 does not equal 0. Now, if that was 5x, then we might have been onto something, and I'll show you maybe one of those later. Okay, so I'm sorry about that. Here we don't have, I thought we could divide them all by 3, but 28 doesn't go with 3. It goes with 4. So there is no actual GCF on this one. I'm just going to have to guess. How do we think they came up with 15? Could be 1x times 15x. That's probably not it. Could be 15 times 1. That's probably not it. More than likely, it's 3 times 5 or 5 times 3. That's just common sense tells me that's probably what they did. So let's just try 3 times 5. I'm going to guess this combination right here. And then I'm going to look at the end. How did we get positive 12? It could be 12 and 1, could be 2 and 6, could be 3 and 4, could be 4 and 3, 6 and 2, 12 and 1. There's lots of combinations on this. Now notice, in the middle, what we're looking for, our O and our I has to equal negative 28. Negative 28. That is a clue that these numbers here are both negatives, right? Negative 6 times negative 2 also equals positive 12. Negative 12 times negative 2, or 1. Negative 6 times negative 2. It's got to be one of these combinations. It's probably not the 12 and the 1. It could be the 4 and the 3. It could be the 6 and the 2. Let me try the 6 and the 2. I'm going to go with this one, and we'll see if this works. We're going to try negative 2. We're going to try negative 6. Remember, here's our target number, negative 28. All right, I'm going to test the outside, the outer part on this one, 3x times negative 6. I'm just going to do that in my head to save space. On the inside right here, negative 2 times 5x. Negative 2 times 5x would be negative 10. Holy cow, we got lucky again. I'm getting so lucky. We're getting these on the first try. Look at that. Negative 18 and negative 10 make negative 28, and that's exactly what I wanted. All right, so let me clean it up a little bit. Here's what we had. 5x minus 6, and this thing actually equals 0. It was actually an equation. So whenever it equals 0, all you have to do is set each parentheses equal to 0. I know this is a multiplying statement with a final answer of 0. So either this parentheses equals 0, 3x minus 2 equals 0, or this parentheses equals 0. I'm going to scoot it over to the side a little bit just to save some space. And then I just solve each one of these questions. And I can do some quick two-step equation stuff, add 2 on both sides. This one, I'm running out of room. It would be 3x equals 2, then you would divide both sides by 3. And so that would leave you with an answer of x equals 2 over 3, right? 2/3. Or over here, you would add 6 on both sides. You would get 5x equals 6. And then I'm out of space, but I would have to divide by 5. I would divide by 5, and you would get, 6 over 5 or 2/3. Okay, that's a lot of work, isn't it? And look, I got it right on the first guess. Just imagine if you had to go through all these guesses. Holy cow, you can see how these can get frustrating. Oh, sorry about that. I have one more board, and I'm about at 20 minutes here, so I'm going to speed it up a little bit. Whenever the book or the test or the teacher or whoever is trying to be as rude as they possibly can, here's what they'll do, right? Instead of giving you something like this, where the original problem equals 0, they will be disrespectful to you, and they will try to give you something that does not equal 0. Okay, are we going to let that bother us? No. Is it kind of rude and disrespectful? Yes. But can we handle it? Of course we can. Whenever it doesn't equal 0 at the beginning, you've got to move all this nonsense over to make it equal 0. Instead of having minus 3, I'm going to do plus 3 because I want it to equal 0. Right? Now, can I actually add 3 to an x? No. Can I actually add 3 to an x squared? No. I just need to write it in the correct format, right? Highest degree down to lowest degree. This is actually my question. Do you see how I had to do that one extra step at the beginning? They were rude, and they didn't put it in the correct format. Like on this one, it doesn't equal 0. It equals negative 8x. I don't want it to equal negative 8x. That's stupid, right? I'm going to have to undo whatever they put out there. Instead of negative 8x, I'm going to do positive 8x. Over here, it doesn't really matter where I put it, because whatever you do on one side, you have to do the same thing on the other side. I know you guys know that. But can I add x squared with a regular x? No. Can I add a plain old number 4 with an x? No. I just need to write this in the correct format. It should go squared, and then x to the first should be in the middle, and then the minus 4 should be last, right? Now, I'm putting a box around those. That's not the answer. That's actually the question, right? So if you want me to work these out really fast, I will try my best. My guess for the 10x squared, my guess is it's probably 5 and 2. It could be 2 and 5, or probably not 10 and 1. How do they get plus 3 in the middle? It's got to be 3 and 1. But look, my oi has to equal negative 1. My O and my I have to equal negative 1. So that's a clue that these are both negative signs. I'm going to guess this combination, and we'll see if it works. Remember, my target is right here, negative 1x. So here on the outside, 5x times negative 1. That equals negative 5x. Here in the inside, negative 3, because it has a minus in front of it, times 2. Negative 3 times 2x, that equals negative 6x. Oh, geez. Negative 5 and negative 6 equal negative 11. I completely failed. I did not get it. All right, so let me try the other one. What happens if I flip it around? I put the minus 1 here and the minus 3 here. I don't think that's going to work either. In fact, I think I might have messed up this question. Now that I'm looking at it, I'm pretty sure I made a mistake. But anyway, I'll give this one a try. On the outside of this one, 5x times negative 3, that equals negative 15x. My green marker is really struggling here. I got to switch it over. It likes to just not show up very well. On the inside, negative 1 times 2x. Man, I messed this one up again. Negative 15 and negative 2 is negative 17. Okay, just to save you guys some time, I'm not going to go through the other examples. I'm pretty sure I messed up this question. I just make these up on my own, and sometimes I do them wrong, like I did yesterday. So I'm just going to call that one off. Let's just try number 2. Hopefully I didn't mess this one up. Let's guess on number 2. The only way they got this, 5x squared, is to do 5x times 1x, right? That's the only way it's going to be. I guess we could have 1 and 5 flipped around, but for now, that's the only way. At the end, how do they get negative 4? Okay, it could be negative. Why do I keep picking up the green? The green is not working. It could be negative 2 times 2. It could be negative 4 times 1. It could be negative 1 times 4. It's got to be one of those combinations. Probably not the one that has 4 and 4. Let me try the negative 2 and positive 2. I guess it could be reversed, but we'll just try this one and see. Remember, here's our goal. The O and the I, we're looking for positive 8. That's our target. So here on the outsides, 5x times 2. That equals 10x's. On the insides, negative 2 times 1x. Ooh, I think we got it on the first try, guys. Look at this. 10x minus 2x. That's 8x, and that's exactly what I was looking for. Okay, so I'm happy. I'm going to kind of erase those underlines so they don't bother people. Look what I've got. I have a multiplying statement that equals 0. So either this parentheses equals 0 or this parentheses equals 0. Okay, and then you just have to solve each one. It doesn't take very long. It's just a two-step equation. By the time you get to this point, you should be happy. This should just kind of be a walk in the park here because this is simple compared to all the other nonsense we had to do, having to guess and check and all that stuff. Look at this. Here's the first answer, 2/5. X equals 2/5. Back up my phone a little bit so you can see that. Or this other side has an answer as well, 1x equals negative 2. Negative 2 divided by 1 is obviously just negative 2. So we have two answers, 2/5 or negative 2. Okay, you know what, guys? I'm going to stop right there. I'm going to put a few of these problems on the Big Ideas Math site for my students. If you're not one of my students and you want some just practice with some of these, I'm not sure exactly of a great site that you can go to for ones that equal 0, but if you just want practice factoring these, like I mentioned yesterday, kudasoftware.com/free.html. On the right-hand side, you'll see a section devoted just for polynomials. And then one of the categories in polynomials should say factoring polynomials, and it'll have in parentheses easy and hard, and you can click whichever one you want. These are considered the hard ones, so you can try those, and if you struggle with them, you can maybe drop it down and try some of the easy ones. The easy ones are the ones you can do in your head. These are the ones where we actually have to guess and check. So thanks so much for watching. I apologize that I messed up this question up here. I'm not a professional question writer, but maybe I'll do better next time. So I'll catch you guys again tomorrow with another video. I appreciate your patience and I appreciate your effort on these assignments, and I will see you guys later. Stay safe.